Hi people, today we're going to work on 5.3, probabilities using counting methods. So this is where the last unit and this unit kind of come together. Really, we could have done the 2 units as one really big one, but I split it up because I thought it made more sense. But really one big unit. We're going to use those ideas now with the stuff we did yesterday, which is to put it all together, make it a probability. So let's just dive in and we'll see how it goes. There are 13 students involved in the SHARP program. NASA will randomly pick 3 students to participate in a cadet program. I don't know what these programs are, but I'll believe you. Determine the probability that Alex, Ryan, and Angie will be chosen. Okay, so let's start off at the beginning here. Probability is number of things that we want divided by number of things in total. Now, these are my 3 favorite people. I want these 3 favorite people to be chosen. So how many ways can I choose 3 people out of 13? And how many ways can I choose these 3 specific people out of these 3 specific people? So just let's write this over the side. I usually find it easier to do the total first. That's just my personal preference, but that's me. So let's pretend the question is just, how many ways can you choose 3 people out of 13 to be in a program? Well, this sounds like a combination or a permutation. And we just need to be careful about which one we use because sometimes it'll make a difference for us and sometimes it won't. I believe in this case it won't actually make a difference, but we're going to practice thinking that through anyway. So these 3 people are just going to be in a cadet program. Does it matter what order they're going to be in? Not really, because they're going to be, doing different things. They're going to be moving around. They don't have specific roles, like one role is not better than the other. So there's no difference in order. So I have 13 people and I need 3 and order doesn't matter. So we say 13, choose 3. And I did this earlier, I got 286. So there are 286 different combinations of 3 people out of 13. So that's my total. I'm just going to put that in here, 286. Now this is my want. I want these 3 people to be chosen. These are my absolute favorite 3 people. And I actually want all 3 of them. So I have 3 favorite people and I need to choose 3 of them. Now it's important that we're consistent. If we use combinations, we continue to use combination. And there's only one way to choose a group of 3 people out of 3 people. So my want is 1 out of 286. We could certainly change that to a decimal percent if we wanted to, but we won't unless they ask us to. Let's try another one down here. A very similar question. Credit card companies randomly generate a 3-digit security code for the back of an individual's credit card. Should you tell people that number? No. If it's like if you're paying with your credit card over the phone, you might have to, but otherwise, don't go broadcasting that to other people, okay? It's a security code for a reason. Determine the probability that your security code of your new credit card will consist of 3 different odd numbers. Okay, so again, probability is want over total. Let's do this over to the side here. Okay, let's start off the want this time, just for fun. Determine the probability that the security code on your new credit card will consist of 3 different odd numbers. So it's not really something I want, that's just the word that I use. I just think it'd be interesting to have 3 different odd numbers. So, how many odd numbers are there? Well, there are, so this is 3 different odd numbers. So there's 1, 3, 5, 7, 9. So there are 5 different digits that could be involved in this security code, and I want 3 of them. Now this time, does order matter? If I had a security code that was 135, would that be different from 531? Yeah, those are 2 different codes, right? So order matters, which means we're going to use a permutation this time. So I have 5 choices, and I need to pick 3 of them. So we're using perm because order matters, and there are 60 different ways to do that. So there are 60 different codes that have 3 different odd digits. Now the total. This is where it gets a little confusing. We have to really think hard. When they make security codes, does it specifically say that security codes cannot repeat or have any other restrictions on it? I don't think so. I think you could technically have a security code that was 000 or like 111. I think that's possible. This 3 different odd numbers, that only applied to something we wanted. In total, though, I think we have a lot more options. So in total, I would say no restrictions. Like, they don't specifically tell us that it can only be different numbers or anything like that. So I think we're allowed to repeat, because it doesn't say we can't. Now, if we're allowed to repeat, we cannot use perms or coms or anything else. We just have to think about it. Here's my 3 spaces. How many digits do I have available to me for the first number? Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 different choices. And if I'm allowed to use the same number here as I use here, then I still have 10 choices and still have 10 choices. So I have 1,000 different ways to come up with the security code. That's separate from the want, which had restrictions on it. So these are kind of 2 different questions in one that we have to then put together. So my want is 60 divided by 1,000, which is my total. So it's kind of weird to feel, because these are 2 very different parts to the question, and then you have to put them together. So you have to kind of separate them in your mind before you try to use it. Alrighty, let's flip and try the next one here. These ones definitely take a lot of practice, that's for sure. Okay, let's see this one. This season's golf team has 11 members. 4 of them are grade 12 students. Each Tuesday and Thursday, I have to set a lineup of 4. Since every team makes the playoffs, I put all the names in a hat and choose 4 of the players to be in the lineup. Determine the probability that 4 grade 12s will be in the lineup. Okay, so I always start it like this. I always say want over total. And then off to the side, I work on it. This is kind of me showing my work. You don't have to do it, but it's nice to show your work. Alright, so let's start off with the total this time. It really doesn't matter which one you do first, because you're going to do both. I flip-flop which one I like to do first. Alright, let's read this again. So there are 11 members in total, and there are 4 grade 12s, and you need 4 people to play on a team. So, since every team makes the playoffs, I put all names in a hat and I choose the 4 players to be in the lineup. So I don't have to be the best 4 or anything. Everybody has an equal shot of being this playoff team. Alrighty, so in total, how many ways can we get 4 people to go play on this team? Does order matter? On a golf team, does order matter? Not really, because they're all just going to, they're going to tee off and they're going to shoot their shot. Depends on order, who's furthest away, right? So it really doesn't matter who goes first, because there's no advantage to going first. So I would say I have 11 people. I want 4 of them, and I'm going to choose, because order does not matter. So there are 330 different ways we could make this team. Now want. Determine the probability that 4 grade 12s will be in the lineup. So I specifically want 4 grade 12s. Well, there are only 4 grade 12s on the team, and I want all 4 of them on here. So I would say I have 4, and I'm going to choose 4. There's one way to do that. So my probability is 1 out of 330. Try it again. Determine the probability of a grade 12 lineup if I had a team of 15. Okay, well, the only thing that changed was this 11 is now a 15. We still only have 4 grade 12s on there. So 15, choose 4, 1365. There's still only 4, choose 4 grade 12s. So there's still only one way to do that. 1 out of 1365. Alrighty. There's one more I'd like to try with you here. Oh no, I lied. There's a couple more I'd like to try with you. So let's keep going. If you feel like you're ready to go, pause me, keep going, and then just check your answers, you know? You might be ready. All right. Harpreet, Megan, Sam, Ravit, Alex, Christina are volunteering with 4 other members of Mr. Asu's class to participate in Shasbury's All-Star Math Team to complete at regionals and then nationals. Mr. Asu was my math teacher back in high school. Determine the probability that Coach Asu will start Ravit, Alex, Megan, and Christina along with one student from his class. One other student from his class, I guess. All right. Want over total equals. Okay. Let's do our want over to the side here and our total over to the side. Alrighty, let's do total first because I feel like that's probably the easier way to go about this. That's the easier part at least. How many kids are in this class? There are 1, 2, 3, 4, 5, 6. 6 of these named kids and 4 others. So there's 10 kids in total. And I need, how many? I think I need, let's see, 1, 2, 3, 4, 5. I think I need 5 because there's 5 spots that Coach Asu wants to fill here. So let's call this 10 kids, 5 spots. Just by counting, there's 1, 2, 3, 4, and one other 5 of this lineup that they want. Now this is an all-star math team, so there doesn't matter who's in which position. So I don't think order matters. 10 choose 5. There are 252 different ways of making this math team. Great. Okay, now for want. So I specifically want Ravit, Alex, Megan, Christina, and one other person. Apparently I don't really care about who the other person is. All I care about is that these 4 are on there. So again, we're using combinations. So 4 choose 4. That'll help me get these 4 people on the team and one other one. So we're going to multiply. How many kids are left? Well, there are 10, so there's 6 kids left. Choose one of them out of there. All right, so there's one way to do that and 6 ways to do that. So there's 6 ways we can do this in total. So 6 out of 252. Alrighty. Last one on this page here. And then we'll try something slightly, kind of more annoying. So we're kind of going to step up here. 103.1 is holding a contest. They have 8 bingo balls, which each have a letter from the word Winnipeg. If the contestant John can pull the bingo balls in the correct order, spelling Winnipeg, he will win an all-expensive trip to Madagascar. That's a random place to go, but okay. Determine the probability that he will win. So, want over total. Set myself up here. Let's do total first, because I think that's probably easier. There are 8 balls in Winnipeg, 8 letters in Winnipeg. So there's going to be 8 balls. And what he's going to do is he's going to pick one out at a time until it spells Winnipeg. So let's think about the total ways we can do this. Now, does order matter in this question? If I spell Winnipeg a different way, like I put the P first instead of a W first, is that going to be a different word? Yeah. So I would say order matters here. I have 8 things. I'm going to pick 8 of them. There are 40,320 ways to pick these balls out of a hat. Now, I specifically want him to spell Winnipeg. So sometimes I think of it this way, Winnipeg. When I'm not super duper sure about how I can use permutations or anything like that, I kind of use my little lines to help me. So this has to spell Winnipeg, and if it doesn't, we don't win. How many W's are in this word? There's 1. So there's one way to get a W there, and if we don't have a W, then we're not going to win. So there's one way to do that. There are 2 I's, and if we skip ahead to the next I, there's only going to be 1 I by that time, because I'll have used 1 up. And same with the N's. Well, there's 2 N's to begin with, but then I'll use 1 N and there'll only be 1 N left. And there's only 1 P and 1 E and 1 G. So there are only 4 ways that you could possibly pick out these balls and spell Winnipeg. So there are 4 out of 40,320 ways to win here. So you're probably not going to win. Now, if any of these things are kind of confusing, go back to counting methods and take a look back at those topics a little bit more, because they are hard. This is not easy, but we're kind of putting together the ideas from counting methods. There's one more on the back here. Let's give it a shot and then we'll be done for today. After a minor argument escalates to a major one, your best friend decides to change your Netflix password so you can no longer use your account. Yikes. Determine the probability that their new password will contain the letters A, B, and C if Netflix does not allow repetition and requires 3 letters followed by 2 digits. So, this is Netflix's rule. So that rule, this restriction here, is going to be in the total. Like, we have to use this rule for the total. We have to use this rule and this rule, the ABC, in our want. So we have to be careful about that. We're going to use this one for the total and both of them for the want. So let's do this. I'm just going to spread myself out a little differently this time. Okay, so let's start off with the total. Apparently we no repetition, and we have to have 3 letters and then 2 digits. So letter, 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 digit, digit. Letter, I'm just putting L, digit, digit. Okay, that's what our, maybe I'll make it look, kind of looks like a 1, hey? Letter, 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 and then digit, digit. That's what our password has to be, apparently, based off this. So in total, how many ways can we get these letters? Well, there are 26 letters in the alphabet, and I need 3 of them. Does order matter? Would a password of LET be different than TEL? Yeah, it would. So order matters, so that'd be permutation. Then for the digits, I have 10 digits, 0 to 9, and I'm going to pick 2 of them. Apparently, that's 1,404,000 different ways to do that, which is like a lot, actually. So there's almost 1.5 million different ways to get this password with these specific restrictions. So that's our total, and we're using those restrictions because they told us Netflix has that rule. Now we're specifically going to use A, B, and C in there. So I'm kind of assuming it's not case sensitive. I'm just going to make a little note here. Assume not case sensitive, as in a big A and a little a are the same. They would mention it if it was, like, you know, it is case sensitive. That's probably what they would say. Okay, so for the letters, you have to use A, B, and C. So you have 3 favorite letters. You want to pick 3 of them. So they can go in different orders, but you're going to use all 3. And then the digits, well, the same rule as this will come into play. 10, pick 2. And there are 540 ways of doing that. So my probability here is 540 over 1,404,000 ways of doing that. 404,000 ways of doing that. Crazy. So here's my answer. I'm just put a little box around it so everyone's really clear about what that is. Now let's make this even a little harder. This time, we still wanted to have A, B, and C in it, but here is the rule from Netflix. Netflix allows repetition and requires 3 letters followed by 2 digits. So still 3 letters followed by 2 digits, but we're allowed to use repetition. So let's do the total first again here. Okay, this time we're allowed to use repetition, so I cannot use a permutation because this says no repetition. So let's think of it this way. There's 3 things. How many choices do I have for the first letter? 26, because there's 26 letters in the alphabet. And then I'm going to use 1, but I'm allowed to use it again, so 26 again, and I'm allowed to use it again. And then there's 2 digits. Again, we're allowed to repeat this time, so we're not going to use a permutation. We can just keep thinking about it. I have 10 digits to use. I'm going to use 1, but I'm allowed to use it again, so times 10. Now this number is going to be quite a bit bigger. 1,757,600 ways. It's more because you're allowed kind of more options, you know what I mean? Now want. I think want is going to be very similar, but maybe a tiny bit different. I'm hesitant to use permutations because, you know, they say we are allowed to use repetition. So I'm going to keep thinking about it like this. Now, you have to use the letters A, B, and C. You can't have C, C, C because you want to have A and B in there as well. So really, can you repeat if you have to use all 3 things and you only have 3 spaces? Not really, because if I could go C, 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 I don't have any A's in there, and then I don't follow the rules. So there's 3 choices to begin with. Let's say it's a C, I use up the C, then I really need to have an A in there, and then I really need to have a B. So this technically is a permutation, just because there's only 3 things and you have to use all 3. But the second part here, they didn't say anything about what numbers I had to use, but I'm allowed to repeat now, so 10 times 10. So it did get a bit bigger just because of being allowed to repeat with the numbers. But really, we're still not really allowed to repeat with the letters. So that's 600, which actually became quite a bit bigger, didn't it? So when my final probability here, 600 over 1,757,600. So it just kind of changed a bit. It didn't drastically increase or anything like that. Now this is going to take a lot of practice. This is not something that you just pick up and go. This takes practice and thinking. Here are some textbook questions to give it a shot. See how they go, ask some questions, and have a good night.